Okay, just as I mentioned in uh, several recordings from both last chapter and this chapter, if they give you the sample proportion, you have to manually enter it. That's where you enter it and leave the number of yeses blank. Okay, I'm going to repeat this. If they give you the sample proportion, you leave the number of yes blank and you manually enter it here. Okay, so level of significance 0.10. Sample size 500. Number of yeses blank, you do not need it because they gave you the sample proportion, so you do not need to enter anything here. The population proportion is 0.7, and the sample proportion, which you must enter manually because they gave it to you, you enter here. And there's where you're, okay. Sorry, the sample proportion does go here, but I inadvertently put in 0.7 before I realized I messed up. The sample proportion is 0.63 right here. If you notice right here, that goes here. This is blank. You don't need it because that's what you're after. And they gave it to you. So just manually enter it right here. Your test statistic here, your p-value, because it's a left-tailed test, is here. Since your p is less than alpha, you reject it. Again, I bet you're just doing the same thing wrong, which is why you're getting these problems wrong. If they manually give you the sample proportion, you must enter it here. There's nothing to enter here. So the level of significance is 0.025. The sample size is 300. There it is down there. Number of yeses blank, you don't need it. Population proportion is 0.3. And the sample proportion, which is given here, is 0.36. Okay? And since it's a right-tailed test, this is this problem, question number 3, chapter 9, in the proportions. So the p-value is a right tail 0.01. Test statistic is 2.27. Oh, well, I imagine this is the same issue. Level of significance is 0.10. Oops. Level of significance is 0.10. Sample size, it's larger. Population proportion is 50% or 0.5. They think it's larger, so it's a right tail test. So when you scroll down, your sample proportion goes here, 0.53, and your sample size is 500. Okay, so just make sure these numbers are lining up. So your test statistic, there it is, 1.34. And since it's a right tail test, there's your p-value. Reject p is less than alpha. Okay, so now you do need to enter number of yes over sample size to get your sample proportion. However, if you just use the same spreadsheet that you just had for the last problem, you're going to need to either get a new one or input the formula. To input the formula, you would just hit equal C4, number of yes, divided by or slash C5 or C2, the sample size, okay? That will calculate your sample proportion now, because that's what sample proportion is, the number of yes divided by sample size. But since you manually entered it last time, you need to put that formula back in the spreadsheet. So just hit equals D3 divided by D2. That's all you need to do. Equals sign D3 divided by D2. Or just go back into the course and grab a fresh spreadsheet. It has that calculation there. Okay. So there are times where you have to enter it manually if they give it to you, and you have to calculate it when it's not given to you. When you have to calculate it when it's not given to you, it's just simply the number of yeses, in this case 42, out of the total number of samples, 62. So level of significance is 0.01, sample size 62, number of yeses is 42. As you can see, it calculated down here, 42 divided by 62 is that. Population proportion is 0.59. And so we have, is it different from? When it says different from, which means they're not saying it's larger or smaller, is it different from? That means it's a two-tailed test, and so your test statistic is 1.4, and your p-value is 1.6 because it's a two-tailed test. And since p-value is greater than your alpha, then you fail to reject, and your conclusion, I'm not going to read it. You could just pause it if you want and read it. It's right here. Okay, and again, 0.01 goes here. Sample size 62, number of yes 42, population proportion 0.49, and you have to go in and manually put in equals D3 divided by D2 to get your sample proportion, which is 42 divided by 62. Okay, level of significance goes here. It is 0.05. Sample size is 400. Number of yeses, okay, so it does need to be calculated. So make sure that this sample proportion right here has this formula in it, equals D3/D2, which is D3 divided by D2. Make sure that's in there. Number of yeses is 220. So 220 divided by 400 is right there, 0.55. That calculates that for you. Population proportion is 0.45. And it says, is it more than 0.45? So it's a right-tail test. Right-tail test. Now, when you see this e to the negative 0.5, that's basically zero. Anytime you see e to a negative number, that's saying move the decimal place to the left 5 places. So every time you see a number that calculates that is so small, it's essentially zero. So you see this e in a negative number, the p-value is 0. So just put 0 here. The test statistic is 4.02, and this is just the sample size times 20. So you take your sample size 400 times 20. It's always sample size times 20. 400 times 20 is 8,000. And now there is enough evidence to conclude that more than 45% because we rejected a null hypothesis. Okay, they want to test to see, is it smaller than 50%? I'm not going to read all the other jibber jab. Okay, so the level of significance is 0.01. The sample size, okay, out of 105 men, 48 on cats. So make sure, again, you have to make sure that equals D3 divided by D2 is in this cell because you're going to calculate it now. The sample size is 105 men. Number of yeses is 48. Got that from right here. Okay, so that'll calculate your sample proportion, which is, after you enter, okay, so 48 D3 divided by sample size 105 D2 is your calculation that goes here. It's going to take this divided by this, okay, and let's see, the population proportion is 0.5, okay, and since they're saying, hey, is it smaller, yes or no, then that's a left-tail test, so 0.19 would be the 4 decimal places, okay, and they didn't ask you for the test statistics, so you don't have to enter that anymore. And since we failed to reject the null hypothesis, there is insufficient evidence that the proportion of men who in cats is smaller than 50%. Okay, the alpha is 0.05. Sample size is 235. Number of yeses is 141. And your population proportion is 56.56. Is it larger? So it's a right-tail test. And the test statistic is, as you see, 1.235, which is here. P-value for a right-tail test, as you see, is right here. Okay. So the P is greater than alpha, so we fail to reject the null hypothesis. These can be a little tricky when you try to figure out what's the right answer. After you read all 3, and if we fail to reject the null hypothesis, that means the population proportion is not significantly larger than 56%, okay? All right, so now the p-value, Okay, the p-value, if you interpret that p-value, p as a percentage, it comes out to 10.84%. Okay, that you need to know that. All right. So whatever that percentage is, in this case 10.84, whatever that p-value is, okay. So if the population proportion, the correct answer is if the population proportion of students who played intramural is 56%. So regardless of the outcome up here, if it is 56%, if it is what they claim it is, that's going to be this number right here. If it is 56%, and if another 235 students were surveyed, so the 235 came from the 235 in this sample, okay? All right. Then there would be a 10.84% chance, and again, that 10.84 came from right here, the p-value, that more than 60%, how did I get more than 60%? Because it's a right tail test, and they said more than, and the sample proportion, that percentage comes here from this sample proportion, 0.6 or 60% of them received the degree within 6 years, okay? All right, and then this one has to, and again, the outcome up here doesn't matter, okay? Okay, if the proportion of students that played intramurals is 0.56, 56 came from here, the population proportion, okay? If it's 0.5, and another 235 students, and again, that 235 comes from here, okay, who played sports, there would be a 5% chance. Where did that 5% come from? The level of significance, 0.05 here. That comes from there. There would be a 5% chance that we would end up falsely concluding that the proportion is larger than 56%. Where did I get larger than? It's trying to see if, is it larger? Right tail test, and that's where that comes from. And again, the 56% comes from here, and the 5% comes from here.